So, this is the other assignment for engineering science. So Adrian's given you one to do, yeah? And this is my one. So, practical investigation to determine unknown component values using DC and AC theory. Alright? So that covers that learn and outcome, apply direct current and alternating current theory to solve electrical and electronic engineering problems. Issue today, due in on Thursday the 27th of April. So you have got plenty of time to write the report up. That's 6 weeks in total there, but we'll look at that to me. Okay? So plenty of time. Yep. Right. Braden matrix. So, on the left-hand side, the things being assessed. Outline the electrical theory behind the practical work. Carry out suitable practical experiments and record results consistently and accurately. When I say consistently, so that you can measure with the meters you've got, for instance, to a specific number of significant figures, maybe 2, maybe 3. Okay? All your results should be reported to 3 significant figures. So if you're doing 1.23 volts and then the next one is 1.5 volts, you put 1.50. They're all then to the same number of digits. You all get, that's what I mean by consistently. Carry out suitable calculations based on the experimental data to determine the value of unknown given components. There will be 3 capacitors for you to find the value of, okay, and the inductor, you'll also be finding the value of that more than once. Right? And then write a professional lab report that details the experimental work carried out and presents and analyses the findings. One of the key things about that is that somebody reading your work could repeat that experiment from what you explain as to how it was done. So, one of the most important points about that I'd like to make is a picture of the equipment means nothing. Because you can put it in there, but it ain't no circuit diagram. Because the person repeating your work with a different inductor, different set of capacitors, different type of power supply, different meters, they want a circuit diagram. How was it connected? Okay? Brief procedure you went through. Not I connected the one wire to this point and another wire to that point. Don't want that. Brief procedure. All of that things were done in. Readings that were taken. Summarise results in a table that you've given a proper title to. I recommend you use the caption system in Word. Right click the table or image, give it a caption, and then you can refer to that number within your text then when you start to write about it. Okay? If you want me to show you how to do that, then I'll happily do that in a minute on the board. Okay? And then the last thing is that usual presentation style, the quality of the written English, and any referencing, if you reference any background reading, the quality of that. Okay? Yep. Everyone happy with that? And the grading matrix is there for you to read, so you understand what you need to do to get a particular grade. Right, for the assignment. Tasks. For this assignment, be required to use theoretical knowledge and the use of practical lab equipment to determine the value of some unknown components. Capacitors and a variable inductor. 2 investigations. Investigation number 1. You're going to be given 3 capacitors where the value of them has been wiped out so you can't see it. Okay, they're labelled A, B and C, and you're to devise a practical experiment to determine the value of these capacitors using their discharge cycle. I will give a brief introduction to both practicals on the board prior to start, so you get an idea of exactly what you're going to do. The capacitors, you're going to discharge them through a meter of known ohmic value, and that's an analog meter, so you can see the voltage going down on the needle. Okay, so that's what you're going to do. And you're better off with the discharge, because with the discharge you can start each, you can always start at the same voltage, whereas discharge you can't never be sure you're fully discharged at a capacitor that was charged up previously. Alright, so that's the reason for using the discharge cycle. Alright, also you won't need to go all the way down to zero. If you remember your theory about the time constant is repeatable. Okay, so what you'll do is do that discharge cycle on 3 capacitors, take the reports, and then you'll write a lab report that has the purpose of the lab work, the electrical theory behind it. Link between lab work and theory should be clear. The equipment you used, how it was set up, in brackets circuit diagram, an outline of the methods used to take the readings, and a clear summary of the results of the practical readings. Clearly laid out calculations used to determine the value of the components from the results. A discussion of the validity of your findings in light of the component tolerances. So remember, these are industry standard equipment that you're using. I don't want to hear lots of things about if I had a better digital meter, I'd have got more accurate results, and all that old guff. Right? Your calculations should bear in mind the number of significant figures of the readings that you can take. So there's no point in measuring to 2 decimal places. There are 3 significant figures, and then after calculation, giving me 5, 6, 7 significant figures in the results. Meaningless. Yeah, so you should be taking that into account. So that's the capacitor side of it. 3 capacitor discharges, determine the values. Okay, once you've got your results, I can give you an indication. I'll give everyone an indication of what the tolerance of those components are, and you can then determine whether your results have that fallen within tolerance. Okay, so you must remember that the capacitance value stamped on that capacitor as a nominal mid value between a plus and minus tolerance. Any component is. Someone put their hand up.
Are we doing the whole class?
You won't be doing it as a class. You'll do it in pairs. You need 2 really to do the capacitor one, because you need someone on a watch and someone taking readings. So that take 2 people. And the inductor, it's nice to have 2 people. But you're going to write individual reports, aren't you? So, all right. You got an odd number, so maybe someone can do it twice then. Right. I can be a passive helper for a person who hasn't got a partner, possibly. All right. I.e., I can write some readings down that someone tells me. Alright, if they give me a table to write them in. We'll see. Doesn't really matter. We'll sort that out. Right, investigation 2. For this investigation, provide with inductor that's a variable inductor. So this inductor's got a core, a laminated core that you can move in and out of the coil. So therefore, we can strengthen or weaken the field in part of that core. We can vary this, and therefore we're going to vary the inductance. Okay? So, the idea of this part is that you can move the laminated iron core. What we've done is, what Chris has done, is marked with tape every 25 millimeters. So you can do this in stage steps, taking readings. The DC current is not going to change regardless of position. We could take the iron core out, put it in. If we was to move the iron core with DC current, we'll see a small change in current for a short time while the core's moving. Got a transient period, but as soon as that stops, it's going to settle back to where it was. But the AC current is going to change dependent upon where we put this core. So the inductance value is going to vary with core position. Alright? So the idea of this experiment is you're going to find the inductance of this in all the core positions. Right? And overall, what I'm asking you to do, that's sort of 3/4 of the way down in the lab report, is determine whether or not the inductance of the coil varies linearly with the core position. So that suggests you graph the inductance against core position in millimeters and see if you get a straight line or how close it is to a straight line. Yep. And then you'll comment upon those results in your own inimitable way. Again, results in tables clearly together with the bit you're writing about them. So I don't want to see in the table below, I want to see in table 3, in table 4, you can see that. Yeah. I'm working hard to try and improve that. That's not been happening on the course. People have still been not doing that kind of thing, even in the third year, still not properly numbering. I'm working hard to change that, because that's about writing a good report that's easy to follow and understandable. Yep. So you're all happy with what you've got to do generally for this assignment, yeah?